So we'll begin this session. In the last class, we were going through the object models, and also we have revised the data models also. In that particularly ER diagram, we were all talking about that, right? So slowly we'll move to the architectural design, okay, then UI design, object-oriented design. Already a little bit we are going through that, right? And we'll continue object-oriented design a little bit, and then further we move. But before that, let me share with you. Yesterday, you all people have received the notification for the internal exam 1, 2, 3. Ashish, am I right? Ashish?
Yes, yes,
Yeah,
yes.
yeah. You keep on responding. Keep your mic again unmuted, right? Now look
Sure.
into look into this. It's an open book test, right? And you'll be writing 5 minutes before that. I will make a different teacher have a different mechanism, but 5 minutes before that, all teacher will make question paper available to you. Question paper pattern is same, right? The open book test, you can refer anything except copying from others. So if at all it is found that okay, answers are same, then things may not be go good, right? I'll make available question paper 5 minutes before the exam schedule, whatever they announce in this particular Google class. You all people will be writing, okay, those things on a A4 size sheet, writing USN number, right, IA1, course code, course name on all the sheet, right? And you will be submitting that one, a scanned copy of that uh, as a PDF, attaching to this Google class, right? And please remember one more instruction. I think Ashish and Arpita, you people can tell whatever the submission you have done so far, right? My drive is full now. I'll be deleting all the things. I'll be deleting all the things except the class test, whatever I have conducted, right? So what you will be doing is you will be resubmitting that in the sense, right? You will be writing whatever you have from the first assignment to ninth or 10th assignment, whatever it is there. That PDF, you store it in Google Drive. Short URL, you are attaching
Short
it here.
URL.
Yeah,
Yeah, yeah.
that you are
Yes.
attaching it. Today night, I'll be deleting everything, whatever you have submitted so far, except class test 1. Got
Okay.
it?
Yes.
So that I can create a space so that internal exam 1, 2, 3, I need to accommodate that in my Google class. Not only your class, there are many other classes. Got it? So I need to create a space for that. I'll be doing it here. Right? Is that instruction okay for you all people?
Yeah, sure.
Right. So with this introduction, any question about the internal exam 1? Any question about the internal exam 1?
From our side, there's nothing but if other students, if they have any
If they
interest
ask, if
in,
they put it in the chat box, right, you
yeah,
can read at
that'll be
any
fine.
point of time. Okay, let me get into the chapter number 3, right, and also some of the questions. Okay, I hope that our question bank, in class question bank, probably will help you to prepare. Please look into that, to prepare. Okay, it is not the same questions, right? There are many challenging questions also in this. There are many challenging questions. I'll take you through the latest whatever that is available. Red color one, that really makes some challenging task to you people. Black and white, they are all routine kind of things. Now let's look into that chapter number. No, not this. Yeah, whatever we have done, chapter number 3. See, prepare a use case model for the following business story or scenario. Here, maybe one page or something will appear. Okay. Now, similarly, there are many things being given. List and explain with example the following system models. Data flow model. In that case, you have to create an example. You have to create a scenario, right? There may be a question where you will be asked to create a scenario and write it, or scenario will be given and you will be asked to write any of the model, right? Please go through this particular book. Okay. Somerville, it is a textbook. Every line of that, you please go through, right? So without fail, Somerville, you can get into any edition, doesn't matter. Look at that, prepare a data dictionary for the following scenario. Here are the few examples given, right? that should help you in understanding what kind of test that we are going to conduct and all, right? But questions will be unknown. That is certainly true. Questions will be unknown, right? Uh, Consider the following scenario and prepare the this again. I think it is a repetition. Now, ER model, right? Prepare relation schema for this, or story will be given. You'll be asked to create ER model as you see in question number 12. Got it. So this is how things will get into. Look at the 15 question. Prepare business scenario to explain the following key concept: has a relationship and is a relationship. Please remember, in all such cases, scenario or the story, they are more important. They are more important, right? So with this introduction to how do we conduct exam and all in this course, every course teacher will tell you about that, but there are certain commonalities, right? Conduction of exam, right? But in our case, what kind of questions that we probably focus, that already we have started doing it. As many as around 70 to 80 questions already we have put it here, right? Any question at this stage? Any question at this stage? Ashish and Arpita?
No, sir. From my side,
Okay, that's good. Okay, in that
nothing
case,
to
yeah,
chat.
in that case, let's get into the other remaining part of the chapter number 3. We are in the chapter number 3, which is in fact a portion for the IE number 2, right? And I told you that
Yes.
I'll be conducting a test on Saturday, class test for you people. Got it? Okay?
Oh, okay, sir. Yeah.
Right. Okay, timing. Did I tell any timing to you people?
No, no, sir.
I will inform you, right?
Yes.
So
Yes.
let's continue whatever we were doing in the last class. Uh, uh, Let me use a marker. 1 minute. Right. 1 minute. Yeah. Right. As I told you that already we have gone through the state diagram in FFL in full length in this in case also. Sequence diagram, that also we have gone through, right? A class diagram we were saying in the previous class. Let's get into this aspect once again, right? See, here are the examples given in your textbook, right? I gave an example. Here, this is the aggregation, right? And if you use arrow mark, that is called inheritance, right? What is the meaning of this particular thing? Is that study pack has assignment, OSP slides, lecture notes, videotapes, has a relationship, right? So this arrow mark, whatever that is being used in the book, is a wrong things. Don't follow it. Right? What is that? I'll tell you. Okay. Don't use this part. It's a wrong thing. Right? Don't use these things at all. Right? This particular thing, it speaks about aggregation. Got it? So what is the meaning of aggregation? Study pack is made up of assignment, OHP slides, and all these things. And how do you write a code for that? Also, we have seen it, right? So probably you may get, because it's the open book test, you may get that following is the object class diagram. Write Java code to represent this, a pseudo code to represent this, right? Ashish, you can note down. You can note down, take a screenshot and put it. Write a Java code skeleton for the following class diagram. Ashish, note down. All of you can take a snapshot of this. It is there in the book, right? Black and white, everything is from the book, Somer Valley, right? Ashish, did you write in your in-class question bank? Ashish?
Yes, sir. Sir, I was taking a screenshot. I'll just
Yeah,
update.
right. Write a Java code skeleton for the following class diagram. How does your Java code looks? And also we are told, please remember, right? One more class diagram we said, this also you can note down, right? This is inheritance, right? and class A, and you have a class B. Assume that class B is inherited from that. For this, the Java code is known, right? This particular arrow mark, okay, that is different, and diamond shape at the end of the line is different. Diamond shape speaks about the aggregation, right? Is that okay? Shall we move to the next one? This is what we have seen in the last class. Okay?
Yeah.
Right. Okay, sequence diagram, that also we have shown. The very purpose of the sequence diagram is to know for a given scenario, for a given flow. Please remember, for the given scenario and given flow, right, you'll be writing a sequence diagram. That is, right, who is an actor using that, what all the object they participate, right, and how to, in what order they interact with each other, right? That makes a given scenario. This we have seen it again full length. Just to recollect, let me take you back to that particular slide where we have referred this. 1 minute, you wait. I'll take you to that one. You have to wait for a minute. Yeah, here it comes. 1 minute. Yeah. Look at that. So we gave an example about this. Consider the use case withdrawal, right? In that there are many scenarios. One is successful cash withdrawal, basic flow, and these are the different alternate flow. And we have written a sequence diagram for one, okay, withdrawal, and scenario within that is a basic flow. Withdrawal is a use case and scenario is basic flow, right? What all the different object participate? Card reader, ATM screen, account, cash dispenser. How do customer interact? Insert a card, please follow whatever I'm saying. Card reader reads a card, then it is initialized the screen, ATM screen, and screen says that hello, good morning, welcome to this. You enter the prompt for the PIN. You enter the PIN, try maybe 1, 2, 3, whatever it is there, because I'm speaking about the basic flow. Here I assume that PIN is all right. Then open an account. Account is an object. It verifies a PIN, right? Then PIN is okay. Prompt for the transaction. You enter the transaction. Okay, here is a withdrawal. You enter the amount, prompt for the amount. You enter the money, withdraw fund. That particular method is being called for the account. Okay, verify the fund, deduct the fund. Then provide a cash, provide a receipt, and cash dispenser will call method of a card reader saying that eject the card. So this is how a particular scenario is being modeled, perceived using sequence diagram. This will help you to design the test cases, I told you, right? Hope this is all clear. Ashish, use of sequence diagram, which you already covered.
Yes, yes.
Okay, that's good, right? I'll keep moving to the next one, black and white coverage of the textbook. Wait for that. Yeah. This is the sequence diagram we were all talking about, right? Now let's get into the other one, right? How do you, a modular approach, how do you achieve it, right? You may draw the class diagram, and this class diagram, you will group it, and that it may be pertaining to particular module, and that is what is called package. Probably in Java, you might have come across the term package, am I right? Ashish, am I right? Package, you have come across in Java?
I don't quite remember, but I guess so.
Yeah. Okay. Packaging is nothing but, okay, your school bag, right? You put all your compass box, notebook, textbook, everything, you package it, right? Inside that one, you have a tiffin box. You put all eatables, right? And package it, right? So,
Yeah,
like
yes, yes.
yeah, exactly like that. Okay, now look at this. It could be diagram also. Consider that, okay, geometry, okay, you have one grouping. You have got a calculus related all class diagram in grouping, integration related all class diagrams grouping, right? That is put under mathematics as a bigger package. They are nothing but the basket. Are you getting this? Right? So when you do a package has its own name. right? And look at the notation for the subsystem, right? Subsystem sorting, right? Okay, subsystem sorting. Okay, you have a data storage inside and you represent like this, right? This is the notation used to represent subsystem. Printing is a subsystem here. Sorting is a subsystem here, right? So this concept introduces what is called subsystem, right? Component, right? Packages, right? This is nothing but a component. Component is a group of objects, right? And subsystem is shown here like this, right? Packages is shown here. This is the diagrammatic representation which you will be using as a part of your design document, right? Maybe there may be one more question, right? How do you represent package? How do you represent subsystem, right? How do you represent component? Correct. Yes. Now look at the few questionnaires, right? Questions given at the end of the book. The questions given at the end of the book will serve an important learning material to test your learning, right? I'll give an example here. Look at this, very interesting one. If you can solve the question given at the end of the chapter, I think you are ready for the placement, almost. So look here, draw the state machine or state diagram of the control software for an automatic washing machine that has a different programs for different types of cloths, right? Correct. Now this is an incomplete description. With only such thing, it becomes difficult for the people to provide a solution. In that case, what happens is you will be elaborating that. You'll be rewriting the problem statement. Okay, what do you mean by different types of cloths? Right? How different types of cloth has a different treatment given in washing machine. Right? If you can describe, then only, right, you can draw the state model. Otherwise, it becomes difficult for the state model. So sometimes such a vague questions also may be given, and you need to elaborate that. Without elaborating that one, you cannot. Got it? Are you clear, Ashish?
Yes, sir. Yes, sir. It's pretty.
Right. Okay. Then look at that. I'll read here. Draw the context model. Context model is nothing but it is something like an system components. It is like an architecture, right? System component and their connectivity, right? For a patient information system in a hospital, right? So this is incomplete. What is the patient information system in this one? Unless otherwise details are available, okay, it may not be possible to write it, right? So look at that. You may make any reasonable assumption by default about the other hospital system that are available, but your model must include patient admission system and image storage system for x-rays as well as other diagnostic records. Got it? So it is allowing you to visualize, right, all possible things, components that makes hospital, and then prepare a context model, right? Now look at that other example. Based on your experience with a bank ATM, draw the data flow diagram modeling data processing involved when customer withdraws cash from machine. So when you talk about the data flow diagram, you know that one, okay, you need to identify different process that makes withdrawal and the initial input. Then how this input is get transformed by each of the process which you have identified, right? So you have to make, okay, visualize the environment and then write the answer. Sometimes it will be as simple as this 1 or 2 line question, or it may be as big as 1 page description about, could be a hospital or could be working of an washing machine, right? Or could be the withdrawal process of money in the bank. Then you will be asked to do something. And please remember, okay, don't expect that similar kind of questions, whatever that, okay, we are solving or going through that one, you get in the exam. No, right? So I hope that this particular slide is helping you. How do I prepare? How do we prepare for the exam? Ashish, am I right?
Yeah, yes.
Okay, please remember, you have to answer it to for all such vague questions, right? A concrete answer, a very crisp answer, very perfect answer, right? And I'm reminding you people, look at that. There will be a lot of ambiguity or vagueness or missing information. In that case, you need to elaborate. For example, an automatic washing machine that has different programs for different types of clothes, right? State machine model. Priyar, what is this different programs? What is this different types of cloths? How do they treat and all? Everything is missing here. And it is all intentional. Remember, until unless you rewrite problem statement, right? Detailing, giving a details of what you understand from this different programs and different types of cloths, right? Whatever the state diagram you write will get a big zero. Remember, until unless I'm telling you big zero, 3 zeros. Until you make it clear different programs, clarity, until different types of cloths, and to that your assumption, right? Writing a state diagram. And please remember, if it is asked for 12 marks, if it is asked for 10 marks, you cannot write simple. The marks and the complexity should match. Take it very simplest form and say that one, look, this is what is the model, right? No, you cannot do it. You as an engineer have to go to the reasonable depth and try to answer the questions. Are you getting this? So anyhow, this is a part of the I number 2. It is not part of I number 1. I number 1 is different. Let me tell you about that. I number 1, what its focus. Let me check it once again. Right? Right. Look at that. I number 1 focuses only on critical systems, software processes, like a requirement engineering. Right? So on this, it focuses that. Got it? Right? So I number 2 will be models that will be a little heavy. I number 3 will be on verification, validation, testing, and project management. It will be again heavy, right? I number 1, okay, majority places is the theoretical, but we don't ask theoretical things. We'll try to convert that into the one which will really test your understanding. Got it? Right? Yes. So I number 1, don't miss that. I number 2 and 3 will be of more doing part, no theoretical things, absolutely. Sir, any question? I mean, students, okay, any questions at this stage? Now look at that, I number 2, a kind of preparation, right? See here, develop a sequence diagram showing the interaction involved when student registers for a course in a university. Course may have a limited enrollment, so that now this is the kind of a statement you get it. Your software engineering, okay, examination is collection of such questions. I wanted to know from you, is that okay? Shall we move to the next one? Ashish?
Yeah, yes.
Yeah.
There are no questions in the chat.
Yeah, that's good. That's good. Right? Right. So now look into that. Okay, the another class diagram, right, which speaks about, say, portfolio. Now there are 3 parts in this. Since it is given in the textbook, I need to mention about that. So I told you a class is represented with the 3 compartments. One is the name of the class, other one is all its attributes. They are nothing but okay, variables used in the class. Then you have all methods or services provided by a particular object, right? So we say that one, these methods and attributes put together, we say it's a property of a particular object, right? Now let's try to read this particular class diagram. I told you, what is this? Ashish, what exactly this symbol stands for? Ashish,
Yeah, yes.
what is that symbol stands for? Aggregation, right? So,
Yes.
yeah, portfolio is made up of one or more investment in this case. One or more investment, right? One or more investment, remember, look at the screen. One or more investment. Got it. And every investment is made up of transactions, right? And look at that, there are two types of transaction. One is deposit transactions, other one is withdrawal transaction. And this symbol, in this case, it is used here, but in fact, all of you can take it as an inheritance, like this. You can correct it, right? So it is something like that. Look at that. Okay, there are many portfolios in the given organization, right? Every portfolio, I mean, okay, does certain computing, certain rate, okay, compute rest, compute results, whatever that is there, right? And this particular portfolio is made up of a collection of investment. Every investment has a name, every investment has a rate, right? You have to compute the rate, store it in the rate. And this investment is on mainly two types of transaction. Every transaction, okay, has a commonality in terms of the date and amount, right? And there are two types of transaction as listed below. The first one is deposit, right, which provides service of get amount, which will take the amount, store it, and date of performing that transaction. And computing a rate is calculated on that amount. Then withdrawal, right, similar to that one, again it has a date and amount, and services provided through get amount, this one. So that makes a portfolio. Okay, that's how a business scenario for this given class can be read. Now, what is more important is, how do you write a Java program for this? Probably I may ask you, create a Java code skeleton for this. You need not have to write really the detailed stuff required for the class, but class skeleton you can write it. So that may be the kind of question that you may get it, right? Okay. So there's another diagram showing about, look at that input file, get investment details. Investment details are transformed into compute rate for each investment. These particular things are being transferred to compute overall return rate, compute other amounts and all, print the result. It is a data flow diagram. Hope you understand that, right? So for again small scenario, you may be writing small data flow diagram or bigger data flow diagram, simple, any unknown scenario, right? Some of the architectural design, okay, that we will get into, given in the textbook, right? Some theoretical things. Why do you go for this architectural design, software architecture, or even we have in our institution software development cell, right? We have a member Ananda Pashupati, right? Govind, okay, Yashoda, right? There are many people, right? So yesterday I was talking with them, right? We need to develop an overall architecture. We need to develop, okay, the architectural skeleton, a code, a working prototype and all. Why this is required? Why this is required? The reason is that one, okay, different stakeholder can communicate with each other, right? Then system analysis, okay, making the system architecture explicit at the early stage in the system development requires some analysis. Architectural design decisions have a profound effect on whether the system can meet critical requirement, maybe a performance, reliability, maintainability, right, etc. How do it looks for the end user, right? User feel that okay, they can they are seeing something on the screen also, right? Maybe when you have an architecture, there are several components come into picture. Okay, probably there may be a reuse of some of the components, right? One of the component of one module can be reused in other component, other module and all, right? Probably architecture model, again, rightly said, is a manageable, compact, manageable description of how system is organized, right? It's an overall perception, overall idea of what is a system. It is at the prototype level, right? So that we need to understand and develop an architecture, right? And remember that these architecture diagrams, that is a template, right? Template for what? Template for system that is being designed, right? And also how system is distributed across number of processors, depending on, right, how they are going to get deployed where, right? All many things it speaks about that. And when you talk about the architecture models, there could be static structural model, it may be dynamic process model, it may be interface model, relationship model, distribution model. Different people talk about that. Okay, this. When you talk about distribution model, it shows how subsystem may be distributed across the computers. Don't think that whatever the software you are developing, okay, it reside at one place only, centralized. No. Okay, different modules will go and get installed at different places, different cities and all, different servers and all, yet they communicate with each other. Got it? Relationship model shows relationship. A best example which we have gone through is a data flow. Data flow between the different subsystem, a process. That can be called as a relationship model. You can talk even ER model as a relationship model, relationship between the different entities. How they are dependent on each other. Right? Then static model, okay, how subsystem or component that are to be developed as a separate unit. A class diagram is the best example, right? The structural model, right? Now look at one such simple thing, the architecture of a particular thing, particular system, whatever it is, right? So you have different components, design editor, code generator, program editor, report generator, design analyzer, right? Design translator, and you have a common repository called project repository. This can speak about the architecture. There are many examples that people talk about that. So look at that, the architecture of a film and picture library system. You have multiple clients, through the internet you communicate, and there are several subsystems like a catalog server, library catalog, video server containing a film clip files, a picture server containing digitized photographs, a web server containing a film and photo information, right? So there are multiple servers and what they contain. It gives overall idea what all the things, where all the things, and how do the system made up of. In fact, software engineering is learned by practice. You cannot read it. It's a common sense. You cannot read and reproduce. Hope you're understanding that. Okay. Look at the layered model. See here, right? It is something architecture for one system. Now layer model, probably in the computer network you might have gone through ISO OSI model, right? What exactly is that? Layered model, right? Why layered model? What are the advantages and all? That are the different issues, right? See, look at that. You have one layer sitting on the top of other layer and providing certain communications. These are all abstractions. Please remember, the abstraction, the use of an abstraction in layered model is that, okay, anything that you alter inside a particular layer do not affect the another layer. That's the benefit of use during the maintenance phase of a product, right? But here it speaks about what all the layers, what are their functionalities, right? How do they get connected with the underlying layers and all. Got it? That is limited to this in this example. Okay, I'll skip this and I'll come back to this. Now look at the pipeline model. Pipeline model, when you look at that, there is something, the internal basic mechanism is a push and pull for the information, right? When a water flow in a pipe, you know about that one. You know, okay, there is a push from one end where you have a high pressure. Similarly here, okay, look at that, invoices are being read, okay, read issued invoices, then that is being pushed to identify payments. This in turn, whatever that is there, the data generated input, okay, converted in output, that is being pushed to, okay, issue the receipts and all, and it keeps moving. It is pipeline. Okay, every pipeline has a stages. Every stage is nothing but what exactly kind of a computation or the processing do, right? So this is being referred as a pipeline model, which very well you can see in a compiler design. Hope you are studying that one. Am I right, Ashish? Compiler design you are studying?
Yes, sir. Yes, sir.
Yeah, what is that is being showed is a push and pull model in different lexical analyzer, parsers, and you have, okay,
Yes.
there are different phases that is being shown, right?
Yes, sir.
Yeah. Okay. Another important thing this particular author discuss is a call return model. Call return model, basically when you, okay, probably when you are studying the recursion, you definitely use call return model is only the principle to understand the recursion much better. In parser, probably recursive descent parser, RDP, you might have gone through. Did you go through that, Ashish? RDP?
I think not yet, sir.
Yeah, it is a outdated parser, right? Probably that's the reason why it might have been removed from the syllabus also, right? There it is a heavily, okay, heavily it makes use of the recursion, right? How do you understand for a given input, right? Is a call and return model. See, best example here to understand the example given here, right? Please look into that. Finally, this is though theoretical that appears, you have to use this when you are working with a complex system. Main program, right? You have routine 1, routine 2, routine 3, then routine 1.1, 1.2, that's how it is being scripted. Now look at the next slide, right? Look, right? Main program, okay, read numbers. From this, okay, parameter A and N goes there. A and N is being passed to the sort, and sort will give a sorted A, right? This, while sorting that one, it will pass X and Y, whatever it is there to switch, and X and Y it gets switched. So it is a call and return. What it does depends on the domain, right? Now the main program having got all the things, A and N, right? Probably, right? The A is an array, N is a number of element. It passes to the add N and it gets a sum of that. So here, the whole system can be understood in the form of the call and return, okay, model, and is more useful in case of what I can say recursion, wherever the working principles are heavily using recursion. You can study, understand using this, right? Any other thing you wanted to know at this stage, Ashish and Arpita?
Yes, sir.
Yeah, this is a more of common sense. This is a more of, okay, the freestyle of working. It is a more of your application of knowledge, right? Nothing can be remembered here, because anything you remember that does not appear in the true life. Anything that you remember by doing that capability, you are using it to solve problems. That's all. I'll give a 10-page big problems containing so many things, modules and all. I'll ask you, right, prepare a call return model for this. I'll give a program to you, and I'll say call return model. Prepare. I'll give a program to you, okay, where different things will call different, say, functions. One call, another function. There is a complex call and return. To understand that one, you go for the call and return model. Got it? So the session is getting closed now, right? I will stop here, right? And we'll continue. We are near to the completion of the third chapter, right? 50% of the IA2 portion. We are near to that. So we'll conduct a class test also on Saturday.
Yes, sir.
The preparation for IA1. All these things will not include. IA1 portion, based on that, we'll conduct a class test. Not on all these topic, right?
Okay, sir. Yeah.
Yeah, okay, everyone has to attend. I'll announce the time for that. Okay, let's see, depending on my convenient time, right? So I will end the meeting here. Thus,
Yes.
right. Okay, bye.